Okay, today you guys, we have this bell work, and then we're going to learn about something called conditional probability. But before we do all that and correct the assignment, I have an extra credit assignment here for anybody who wants to do it. It's not difficult, but it'll help remind you a few things and a couple things you might not have known. You'll probably have to look some of it up on the internet. So raise your hand if you want one in this row. Want one if you want in this row? Wow, everybody wants it. Huh?
How many? Is it one page or 2 pages? Your report on that?
No, this is the extra credit for this quarter. Anybody want it?
What if I already did the report?
Sarah, Carly, do you guys want some or not?
Save for next quarter.
Okay. This is not the 10 times project. Do you guys want some? Yeah, let me just a third of a letter grade. Okay. Whoa. Okay, now, you guys, this is only, just so you know, it's going to be the very last thing I put in your grade, and it will only raise your grade a third of a letter grade. So if you're getting a B, it will move it to a B plus. If you're getting a B plus, it'll move it to an A minus. If you're getting an A minus, it'll move it to an A. Right now, I just checked the grades. Everybody has at least a B or higher. So, okay.
How do you write 50?
Okay, now, let's go over these. I'm gonna pick on a couple of you. I'm gonna start with Sarah. When rolling two dice, number one, what is the probability of rolling a sum that is greater than 7? 5/12? Everybody agree with her? Okay, because there was 15, right, out of 36 that worked for that. Is that correct? Okay. If we wrote this as a percentage, what is it, Delisa? 41 point what? So if you wrote as a percent, you got 41.67%. Raise your hand if you know how to change it to a percent. Some of you guys don't know? 5 divided by 12, right? And move the decimal place over to the right twice, right? Okay. All right, number 2. What is the probability of rolling a sum that is odd? Mr. Last. Alex. What is the probability of rolling a sum that is odd? You know this. You have this table. Huh? What? Okay. It's 1/2, but why is it 1/2? Okay. How many possible outcomes are there in when we roll two dice? 36. Remember the table that we've drawn in the past? Okay, and half of them are going to be odd, so it's 18 out of 36, which reduces to 1/2. Okay. Number 3. What is the probability of rolling a sum that is greater than 7 and is odd? Hannah, what do you think? If it's going to be it has to be greater than 7 and it has to be odd. So, do you have your table somewhere? Do you guys all have your tables out? I'm going to come back to you, Hannah, on that one. Okay, number 4. Are the events rolling a sum greater than 7? Well, I guess we need to answer this question before we answer number 4. Okay, so I'm going to ask Jalee, number 3. What is the probability of rolling a sum that is greater than 7 and is odd? 1/6? Okay, what did you get originally? 6 out of 36? Okay, so there are 6 odd numbers that are greater than 7. What are they? The 9s and the 11s, right?
Yes.
3 9s? No, 4 9s and 2 11s. Is that what there are? Okay. Is that right? 4 9s? Oh yeah, that would be right. 4 9s and 2 11s. So, and that's 1/6. Good. Okay, so last question. Are the events rolling a sum greater than 7 and rolling a sum that is odd independent? Justify your answer. What do you think? They have to be 7 and odd?
No, if it says 7 and rolling some that is odd, they don't have to be the same.
Well, are the events rolling a sum greater than 7 and rolling a sum that is odd independent? It has to be what? Yeah, so it has to be both, right? Okay, it does. Oh, I guess it doesn't say that in that problem. Are the events rolling a sum greater than 7 and rolling a sum that is odd independent?
Well, are you just rolling it once?
Yeah, you're just going to roll it once.
Like you're trying to get greater than 7 and off.
So you're trying to get both. Huh? Yeah, they depend on each other, don't they? That's what I was saying. That's what you guys are. I thought you were saying independent, weren't you?
No, I was trying to say.
Okay, all right. That's why I was confused. So, okay, yeah. All right. You guys got that? Okay. That's your last bell work, right? Okay, we're going to turn it in. Whoops, sorry. This is number 10. Okay, so 6,500 over 100 and 1320 is it reduces 1320. So, what's the chance that you're going to how many times are you going to pick a person?
4.
And are you going to put them back each time? Yeah, it says with replacement, doesn't it?
Just as if they're chosen out. Say that they were replaced.
They don't have replacements.
A nationwide survey shows that 65% of all children in the United States dislike eating vegetables. If 4 children are chosen at random, what is the probability that all 4 dislike vegetables? Oh, you know what? It doesn't say replacement, does it?
Hey, let's just say it is.
But I asked you and you said it was.
Yeah, I thought it said. That's why, because I thought it says it was. Okay, well,
Just cross out one out.
I guess if you
Let's just get rid of that one.
choose them all at once, what?
The beginning on this first paragraph says that none of the problems like the first one affect the second.
Yeah, it does. We're just going to say that it's with replacement because Colby's right. Okay, because this was an independent independent probability assignment. So, all right. So what am I going to do to figure this one out? Times what by each other 4 times? 13/20ths. By the way, do you think when you're all done it's going to reduce? Did you know you could tell right now that it's not going to reduce? Because nothing here will cancel, nothing on the top will cancel anything on the bottom, right? So you know the final answer is not going to reduce either. So whatever you get, that's going to be it. All right, are we ready to correct it? Okay, here we go. Everybody pass it one person backwards. People on the back, pass it all the way to the front. Except for Kai, you're going to pass yours. Okay. On the paper you got circle number 7, number 6, number 1, number 5, and number 2. 1, 2, 5, 6, and 7. Those are the 5 we're correcting. Okay, number 1, what is the answer? 1/25. How many of you got that? Is that right? Okay. All right. Today, we're going to talk about conditional probability. And guess what? I have to tell you this. I had never learned about conditional property until I found out I had to teach it today. Okay? And last night I spent 2 hours here learning about conditional probability. So I want you to know I don't have it all the way down yet. But I know the idea. I just saw the notation. I keep getting confused. So I I'm kind of learning this along with you, okay? But I did spend 2 hours last night studying it pretty intensely, and I made up this assignment, okay? But after I'd made up this assignment, I found this better website. I had explained it better. And so maybe what I'll do is I'll tell you, I'll have to go look up the website again. I didn't put it on here, but I wrote it on this paper right here. But we're going to talk about, first of all, independent and dependent events to do this. And if you guys will notice right here, your objective is you will learn how to use conditional probability. You need to know these two notations right here. Okay, I'm going to write it on here for the people who aren't here today. Probability of B given A is equal to the probability of A and B, which is the intersection, divided by the probability of A. And we can write it the other way around. The probability of A given B is equal to the probability of A and B divided by, thank you, divided by the probability of B. Okay, so that's the notation that you're going to use. So the basic concept right here is it has to do with dependent events, and we're going to talk about those in a second. The probability of B given A, that slash right here, see that slash right there? Read it as given, or, I mean, one of the sites I looked at used the word assumed. I can't remember if it's the paper I gave you. Does this say assumed on there? Or does it say given? B given A. So that's what that means. Okay, understand that notation? Okay, so we have to talk about dependent events and independent events. Okay, so if I flip a coin and I roll a die, are those two things independent of one another, or does one depend on the other? They're independent because you have a coin that is totally isolated from the die, right? And so you don't need it.
Question.
Yes.
If you make it so, say, if this lands on heads, and you change the dice 1 over or something like that, then they would be dependent, right?
Wait. If this was heads.
So you roll the dice, right?
Uh-huh.
You get that number. Then you're like, for the coin, you're like, if it's heads, you move it 1 to the left, and if it's tails, you move 1 to the right. Then it would be dependent.
Well, I don't know that you'd still count that as probability because you're manipulating it yourself. You're not letting it decide. But the probability of the coin. So yeah, I guess you could look at it that way. Then the second one would be dependent. Okay. So let me give you an example of dependent events right here. Okay. Because we didn't talk about dependent events much the other day. Okay, let's say that you have a group of marbles. Okay, right here. These are marbles. And let's say that you have 2 blue. Whoops. That was a little bit of a hurry. Okay, let's say you have 2 blue marbles, and let's say you have 3 red marbles. Okay, and these are your marbles. Okay, I want to know, what are the chances of getting a blue marble? Okay, 2/5. Okay, getting a blue with 1 draw. Let's say I have them in a bag, can't see them, and you just reach in there. It's a probability of 2/5. That's simple probability, right? Okay. But after taking 1 out, you change the chances, right? So what are the probabilities of getting a blue marble the second time? 1 out of what? 4. Okay, now, did my second draw depend on my first draw?
Yes.
Yeah, it did, right? And the probability of those two things happening is kind of like when we did the dependent or independent. You multiply those together. So the probability of picking out, reaching in there once and getting a blue, then reaching in there a second time and getting a blue, is 2 out of 20, which is a 1/10 chance. Haley. That's a good question. What if the first time I drew a red marble?
You try.
Well, I just want to know, Haley, all I'm asking is what is the probability of getting this? And so I'm going to assume that I got a blue marble the first time. Okay? And so I have that. But there's a lot of different probabilities, okay? Let me just go through this a little bit right here. Okay? Let's say I did choose a red marble the first time. Okay? Let's say the first time I chose a red marble, and then I choose a blue marble. So what if I chose a red? What's the chances of choosing a red marble first time? 3 out of 5. Okay? 3 out of 5. What would be my chances then of choosing a blue marble? 2 out of 4, right? So getting a red then a blue would be these chances right here, which would be 6 out of 20, which is 3/10. That's chances of getting a red then a blue, right? So do you understand dependent probability? Okay. Now, if we replace the marbles each time, you guys, if we replace the marbles each time, then that would have been what kind of probability? Independent probability. It would have been 2/5 most of the time on this one, and then 3/5 and 2/5 on this one, right? Okay. All right, now, so you guys need to know, if you replace something after you pick it, it's called independent probability. If you don't replace it, it's called dependent probability. All right, we're going to make a tree diagram of this now. Okay? So we are going to start right here. We have 2 blue and 3 red marbles. Okay? I made a sad face. That's supposed to be its nose in the middle. Okay.
It could be a mouthless person.
So we're going to do it this way right here. What's the chances of pulling out a red marble? I mean, blue marble, you guys? Okay, there's a 2/5 chance of pulling out a blue marble. What's the chance of pulling out a red marble the first time?
3/5.
There's a 3/5 chance, right? Now, I need to make those a little bit bigger. Now, if I pull the blue marble out, here's my thing up here. Now, how many do I have of each? Well,
No, you did it wrong.
There's only one.
1 blue, right? And down here, how many blues do I have?
2.
Okay? And then up here, I have
3.
3. And then right here, I have 2. Try not to make these look like faces, so.
It's like if you went. It's like
That
a
doesn't look like a face at all.
All right. Okay.
They're 2 separate.
Now, let's take it one step further, you guys. Let's say, what's the chance of pulling out a blue marble this time?
1/4.
1/4. And what's the chance of pulling out a red marble down here?
3/4.
Okay, and what would I have left in each one of these? I would have, on this one I would have no blues. This one I would have 1 blue. This one I would have
3 reds.
3 reds. And this one I would have 2 reds. Okay? You guys get the idea of what we're doing here? Okay. Now we're going to go down here. Okay, down here we chose a red marble out first, right? What's the chance of choosing a blue marble out? 1/2, 2/4. And what was the chances of pulling a red marble out? 1/2. And what would be left in each one of these circles? Two red here, one red here, one blue here, and 2 blue there. Right? We got that? So, you guys kind of get how this is going? All right, now, if a blue marble was selected first, there is now a 1/4 chance of getting a blue marble and a 3/4 chance of getting a red marble. We went through that, right? If a red marble was selected first, there is now a 2/4 chance of getting a blue marble and a 2/4 chance of getting a red marble. Okay? Now we can answer questions like, what are the chances of drawing 2 blue marbles? What is the chance of getting 2 blue marbles in a row? Which path follows that? No, 2. The top one, right? This one, and then this one. And we already did this once. So the 2 blues, right? 2/5 times 1/4 would make what? 2/20, which is 1/10, right? Okay. Wait. Oh, no, you know what? That's wrong. Yeah, what is it? You know what? I told these guys I'm learning this as we go. What is the chance then? What is the chance, you guys? Huh? No, you guys told me I was wrong. So what is it? There's a 1/4 chance. That's what it says. Okay? It's this one right here. There's a 1/4 chance. So this right here is not right. Okay? Oh, no, it's right. It was right. We were right.
Are we right or are we wrong? Oh, tell us.
You guys made me doubt myself.
I believed in you the entire time.
It's a 1/10 chance. Hey, would you guys listen, please? You guys are being way too rambunctious here. All right. Did you see? Okay, so we got that down, right? Now, this is what we're going. This is the notation for it. Okay, so. Okay, I got to read this for a second, just a second. I'm trying to give you guys a different look at it before we give the assignment. The assignment actually is fairly straightforward. But I'm trying to give you a picture of it. Okay, the probability of A means the probability of event A. I think we've learned that already, right? So if we have the probability of A, that's equal to, that means that it's the probability of event A. Does everybody understand that? And if I say probability of B, and we're going to say probability of A is the probability of getting, we're going to say it's the probability of getting a blue marble first. Okay? Probability of event A is the probability of it getting a blue marble first. Okay? Now, and what is the chance of getting a blue marble first, you guys? 2/5 chance, right? Okay. Now, probability of B. Okay, that means the probability of getting a B, right? Event B. And we're going to say that probability of B means that we're going to get, I'm trying to find what it wants us to find here. And probability of B is getting a blue marble second. Okay? Now we already know what this is. It was 2/5 plus times 1/4, right? Okay? Or 2/5 times 1/2, wasn't it? Or wait, what was it? What was on the last one? 2/5 times 1/4. Okay. All right. So we say, so this is it right here. So we say, and so we have to say, this one's saying, so we have to say which one we want first. And the symbol, so we're given probability of B given A, is how we say that. Means event B given event A. Okay? Event B given event A. Okay. In other words, event A has already happened. Now what are the chances of event B happening? Okay? And so this is what we use. B given A, right? Austin, you got a problem or something?
I don't understand.
Well, why do you, I mean, how come you have to do it so loud? I mean, if you got a problem, say it. I'm serious. If you got a problem, say it. Okay. Haley. Did you understand what we did right here? Did you understand? You understood that?
Yeah, I got that too. I get what you're talking about. Don't worry.
Okay. Okay, let's back up then, right here. Okay, here we go. Yes, McKinley.
Like, I understand what we're just, I don't get like focus. Like, but it all goes. It's just
That's
a different.
we got to get to the end so you can see it all. Okay? Well, you guys, there are, starting right here. Did you understand? We had 2 blue and 3 red, right? Got that? The chances of getting a blue marble first was 2/5. And then after that happened, given that happened, that we got a blue marble, we wanted get another blue marble. So there was a 1/4 chance of that, right? We multiply them together, we get 2/20, which is equal to 1/10. How many of you get that? Okay, Haley. Yes. That's why, see down here, I'm going to skip back down here. That's what this means. The probability of event B given that event A happened. Okay? So when we come back here, this is saying, okay, what is the event of getting 2 blue marbles? Well, first of all, we had to give the event that A happened. Event A is getting a blue marble. It's 2/5, right? Probability. Event B was a 1/4 probability after we given that event B happened. Do you understand that? And so this notation, that's what it's saying. What's the probability of getting a marble on my second draw given that I got a marble on my first draw? Do you guys understand that? Does that make sense now?
Yeah.
Okay, and that's all this is saying right here. So this tree diagram, it just showed you all the possibilities. Here's our 5 marbles, 2 blue, 3 red. This is the top one is if we drew. This is the chances of getting a blue marble, then a chance of getting a red marble. And then we came up here and we said, okay, if we did draw a blue marble first, now there's only 1 blue marble left. There's a 1/4 chance of getting another blue marble, and a 3/4 chance of getting a red one, the second draw, right? given that that happened already. Okay, and then same with down here. Each one of these is a different given event. Okay, so this is if you drew a blue first and a red first. And then if you did draw a blue first, this is the probability of, in fact, let's write these probabilities up here. This one right here is the probability of B given A, right? And probability of B is drawing a blue marble the second time, given that you drew a blue marble the first time, right? Now we'd have to call these other events, we'd have to call, and maybe call probability of C drawing a red marble, okay, the first time, and probability of D drawing a blue marble or a red marble the second time, right? And so we could say, okay, what's the probability of D given, what would we say? Given A, right? This is the probability of D given A. In other words, choosing a red marble, if D is choosing a red marble the second time, given that we chose a blue marble the first time. You got that? And this one down here is the probability of the probability of B given C, right? And this one down here is the probability of D given C, right? That's what all those are. How did I get 1/10? Okay, this is the probability of drawing a blue marble the first time, right? That's 2/5 chance, because there's 2 out of the 5 marbles are blue. Now, if that happened, there's only 1 blue and 3 red, so the chances of drawing a blue marble are 1/4 on my second draw, right? And when you have successive probabilities in a row, you got to multiply them. So 2/5 times 1/4 equals 2/20, which reduces to 1/10. Got that? How many of you think you understand now? How many of you are kind of lost? It's okay if you're a little bit lost, but we'll come back. All right. Sounds like most of you got this, or all of you, I think. Okay. This is the probability. This is all we're saying. Probability of B given that event A happened. Now, you guys, part of the problem is I'm trying to read it off of here, and I don't know the information on here well enough, okay? So I'm going to, if I need to go back and explain, then tell me to go back and explain. All right, now, I need to show you an equation. So let's go back to this blue marble thing. Hey, your assignment is on the back right there. Read through that information. You can probably get it, Austin. Okay? Okay, you have 2 blue and 3 red. Okay, right? We're going to go back and do this again. You guys, we know that there was a 2/5 chance. We're going to do this again. We knew that there was a 2/5 chance of getting what, everybody? Getting a blue, right? That's what we're going to call probability of A, because A is the event of getting a blue, right? Everybody got that now? Okay, and then the next one, if we want to get a blue again, that was the probability of getting... Oh, wait, I got to write down what we have left. Okay, and then the next one we had, I should have done this. I got to go down here now because I ran out of room. But that's the probability of B given A, right? Yes. So this is the probability of B given A. All right. Okay, so, and then we know to get the answer, we had to multiply those together. We went like this: probability of A times the probability of B given A to find out our final outcome, right? And we came up with 1/10. Now, this thing tells us that that is just an intersection. I'm not sure why it's telling us that. I understood it when I read it last night. Okay, it's saying this right here, you guys. The probability of A and B happening is equal to the probability of A times the probability of B given A. Got it? So that's, well, I guess it's just saying that that's how you could write it, is the probability of A and B happening. Okay, and B is the event you get blue marble on the second one. Okay, so we have this equation. Now, how does this equation look like this, you guys? See this equation, these two equations I wrote down on your objective? What's different? What do I need to do to get it to look like that? Would you do what? Yep, divide by P of A. That's exactly right. So if we divide both sides of this by P of A, what happens here? Okay, and so we get the formula that I gave you the very first class. So it's going to be the probability of B given A. B given A is equal to the probability of A and B, right? Divided by what? The probability of A. Okay? Now, we're going to do a couple of examples. Okay, and using this notation. Okay, and then after we do these couple examples, I'm just going to do 2 examples, and then we're going to look at some of the examples on the packet that I gave you, and then I'm going to let you do the 5 problems. Once we're done, you guys, it'll take you like that to get the 5 problems. It's a really easy assignment, actually. Okay? All right, so here we go. Example, drawing 2 kings from a deck. Event A is drawing 2 kings from a deck. Event A is drawing a king first, and event B is drawing a king second. For the first card, the chance of drawing a king is 4 out of 52, right? Okay, so the probability A is 4 out of 52. So we're going to say, and you guys, this would be easier just to do without the notation, but I want you to understand the notation. Because it's really important in mathematics to understand notation, because then you can do much more difficult problems. And that's why I have to teach you the notation. Because I think you guys all know, let's just do it first. What's the probability of getting 2 kings? Draw one and then draw the other. What do you think? Okay. How many kings in a deck of cards, you guys? 4. How many total cards? 52. So there's a 4 in 52 chance, right? And you're going to times that by what? 3 out of 51. Why? Raise your hand if you know why it's 3 out of 51. Okay, because you already drew 1 king out, because you're given that you drew a king out the first time. Yeah, you assumed, or you gave that you did. And there's only 51 cards left. What does that equal? 12 out of what? What is 52 times 51 first? 2,652. And what did you say it reduces to, Sarah? 1 out of 221. That's what it reduces to, okay? Yeah, we could have. This would reduce to 1/4, and 3 out of 51, I think, reduces to 1/17, doesn't it? No, wait. What does 3 over 51 reduce to? Wait. Yeah, 1/17, right? So that doesn't look right over there, you guys. What's 4 times 17? 68, isn't it? Did you guys give me the wrong number over there? Is 52 times 51 2652? And reduce it in your calculator. What's 12 over 2652? Oh, 1 over 52 is not 1/4. It's 1/13. That's the problem. Okay, what's 13 times 17? Is it 221?
Yeah.
Okay, that looks better. Okay, so that's the probability, but let's say, you guys, let's say that probability of A, let's do this again. Let's say that the probability of A is equal to the event of drawing the king. The first draw. Okay, everybody got that? Okay. And event B is drawing a king second. So probability, event B is event of drawing a king second. Okay, so how do I write this? Probability of what given what, you guys? Probability of B given A, right? It's the probability of B given A. So, really, the probability of B given A is the 3 over 51, right? And the probability of A, what's the probability of A again? 4 out of 52, right? And so I have to multiply those together, right? So probability of A times the probability of B given A. So the probability of A and B is equal to the probability of A times the probability of B given A, right? That's it right there. And we already know that it comes out to be 4 over 52 times 3 over 51, which is equal to 1 over 221. Okay, do you guys understand that?
Yes.
For the most part? Okay. All right. This is easier actually to understand without doing the notation.
Yeah.
But the reason we do the notation is so that you can do more difficult problems, and you can do proofs of them, which most of you guys won't be doing proofs unless you become a mathematician. Okay? You might be surprised. I've had some students become mathematicians. They got their doctorates in math before. They never thought they were going to. So, okay. All right. Let me give you one more example. Let's give it this way, you guys. 70% of your friends. Let's do this one. 70% of your friends like chocolate. Okay. 35% like chocolate and strawberry. Yeah, you can if you want. I love chocolate, but I don't love chocolate ice cream.
I love chocolate.
I don't ever think it tastes like chocolate myself. So, okay. I love chocolate, but I don't like chocolate ice cream.
Why?
It doesn't taste like chocolate.
It tastes like chocolate. It's chocolate ice cream.
Doesn't taste like it. I like chocolate milk.
Chocolate milk is my favorite of anything.
What percent of those who like chocolate also like strawberry? Okay, now. Okay, so the question one more time. What percent of those who like chocolate also like strawberry? So I'm going to write this down. What percent of those, this is like your homework problems, by the way, this one right here. What percent of those who like chocolate also like strawberry? What do you guys think? Who thinks they know the answer to this? What is it? That is right. What did you do, Ryan?
What?
that's what I got too.
What was that? He went 0.35 divided by 0.7, right? Well, you can do it 30 divided by 70. And what did you get? 0.5. You times it by 100 to get your percent. So it's 50%. Got it? Why did that work?
Chocolate and strawberry is the PAN, and then the other one is
Yeah. You guys, the probability of chocolate, okay, here's the probability of chocolate right here. We're going to call this a P of C, the probability of chocolate. Okay, liking chocolate and strawberry was the probability of what? We'll call strawberry S. This was C and S, right? That was C and S, right? And the question I asked, what percent of those who like chocolate also like strawberry? That's the probability of strawberry given chocolate, right? Probability of strawberry given chocolate. Okay, that's the probability of strawberry given that they like chocolate. Well, if we use that equation, you guys, if we use that equation back here, okay, which two do we know, by the way? We want to know P of S comma C, right? So we're going to use these formulas right here. We're going to divide the intersection by the given probability that we have, right? So in this case right here, the intersection was 35%, right? So we took 35% and we divided it by the given. We were given the 70% like chocolate, and we got 0.5, which is 50%. Okay, so we use this. We use this equation, these two equations right here. Okay, the probability of B given A is equal to the intersection divided by the probability that you're given. Okay, so everybody go to your assignment now. All you have to do is figure out which one's the intersection and divide it by the other one. Hey, yeah, like what? Well, okay, are we on number one?
Yeah.
You know what? I don't want to do your assignments for you, so everybody do this first. We're going to go to the examples. Example 1. On the page before, I'm going to let you do the 5 problems, because I've only got 5 problems for you. Example 1. Everybody turn to example 1. A jar contains black and white marbles. 2 marbles are chosen without replacement. The probability of selecting a black marble and then a white marble is 0.34. That's the intersection, isn't it, you guys? 0.34. And the probability of selecting a black marble on the draw is 0.47. What is the probability of selecting a white marble on the second draw given that the first marble was black? So you're just going to use the intersection divided by the one you got. Which one's the intersection? 0.34. So everybody go 0.34 divided by a given 0.47. So what's 0.35 divided by 0.47? 0.72, which is 72%. You can see the solution right there, right? Look at example 2. Which one's the intersection in example 2? The probability that it is Friday and that a student is absent is 0.03. So that's, what's that? Is that the given or the intersection? That's the intersection, right? It's both of them. Friday and absent. Remember, the key word is and right there. That's how you can tell an intersection. Since there are 5 school days in a week, the probability that it is Friday is 0.2. What is the probability that a student is absent given that today is Friday? Well, all you have to do is divide what by what? 0.03 divided by 0.2, and you get 0.15, which is 15%. You guys getting this? Okay, go to example 3. Alex, example 3. Which one's the intersection here, you guys? Okay, so at Kennedy Middle School, the probability that a student takes technology and Spanish is 0.087. So So that's the intersection. He's taking both classes, technology and Spanish, right? The probability that the student takes technology is 0.68. That's the given. What is the probability that a student takes Spanish given that the student is taking technology? Well, you divide the intersection by the given. So 0.087 divided by 0.68, you get 0.13, which is 13%. Let's look at a picture of it now, you guys. Let's look at that Venn diagram. The conditional probability of an event B in relationship to an event A is the probability that event B occurs given that event A has already occurred. The notation for conditional probability is probability of B given A, and as read as the probability of B given A. The formula for conditional probability is probability of B given A is equal to the probability of A and B divided by the probability of A. That's the intersection divided by the given. The Venn diagram below illustrates P of A, P of B, and P of A and B. What two sections would have to be divided to find probability of B given that A occurred? So you would take A and B. Oh, you know what? There were some numbers in there, but you can't see them when I printed it off. So, but you guys, let me show you a picture on that. So you had that Venn diagram, and you had the two intersections. I think there was like 0.2 here, 0.3 here, and 0.4 over here, like that. So this is A, and this is B, right? So let's do this. You're going to just, you want to know the probability of B happening given that A happened. So A happened. Okay, A happened right here. So what is A? 0.5, right? What's the intersection? 0.2. So you divide the intersection by the given. 0.2 divided by 0.5. Huh? Yeah. The intersection divided by the given. You're given A. You want to know what's the probability of B happening given that A happened. Okay? So 0.2 divided by 0.5. What is that? 1/4. Or, no, it's 2/5, isn't it? Did you say 0.4 or 1/4? Okay, 0.4, yeah. 0.4, which is equal to 40%. And that's your answer. It's, you guys find the intersection, divide it by the given. That's all you have to do on this assignment. All of them are the same. Guys, these five problems are due next time. It should take you about 2 minutes to do them. Okay? Haley, you're done. See less than 2 minutes. Okay. Hey, you guys, when is, did I tell you when the extra credit is due?
Tomorrow.
I'm going to say it is due on
Friday.
Tuesday. Due Tuesday. Everybody got that?
Deal.
Wait, all eyes right here for a second. When is the extra credit due, you guys? Tuesday. Everybody got that? Okay.